Hey, Philosophy 102 class. So I made a note at the beginning of the other video lecture, but I want to make the same note here. Because I have assignments due by Wednesday at midnight, and I upload videos uh, on Wednesdays too, there's become this incongruity where I don't get to answer everybody's questions when I make the videos because I pre-record them. So from here on out, I'm going to be separating the homework review from the lecture for the new chapter. So uh, this will just be the lecture, and at the end, the homework assignment, which is going to be a little different this time. And if you want the homework review for the last section, that's in a separate video. That way I can wait to upload that and hopefully answer everybody's questions. So, all right, we are starting deductive arguments, also called truth functional logic. This is what we will be doing from now until the end of class. This is what everything in this class has been building toward. When I said it would come up again later, this is what I was talking about. We're also going to be using a different textbook for parts of the lecture, although there won't be any homework in it. I can upload it for you if you want it, but it's a logic textbook, so, and, obviously we're in a logic section. So I think it handles it better than this textbook for explaining certain things. So don't be too surprised when we go look at that. And if you struggle with this, that is normal. I promise once you get used to doing it, it is as easy as like plussing and minusing. It's super easy. So some notes on this. We're going to be learning how to use truth tables and logical symbols. We're going to learn how to symbolize compound claims, and we're going to learn how to evaluate truth functional arguments using common argument forms as well as some uncommon ones. And ultimately, we're going to learn how to use both long and short truth tables for proving an argument is valid. If at any point you're struggling with this, there are dozens of videos on YouTube that review this and explain it in a different way. And, maybe I explain it in a way that works for half of you, but not the other half. You can always message me, and I will send you some links. They also have different problems you can go over, so maybe you just want some practice with this stuff. This is a very large portion of the final exam, and I want to make sure I emphasize this is what we will be doing until the end of class. Mostly something called truth tables, which they don't mention here. So, I like the background of this. The earliest development of truth functional logic took place among the Stoics, who flourished from about the 3rd century BCE until the 2nd century CE. But it was in the late 19th and 20th centuries that the real power of truth functional logic, which is also known as propositional logic and sentential logic, became apparent. It's called sentential logic because it logics about sentences or propositions. The other textbook we use calls it SL. That stands for sentential logic. You might also see it referred to as FOL or first order logic. These are all the same. This has many, many names because it's been around forever. The reason we didn't really start to pay attention to it until the late 19th and early 20th centuries is because it's what math is based on. It's what set theory is based on. It provides the foundation for contemporary mathematics, but it also is the model for electrical circuits, the sorts that are the basis of digital computing. But more than that, something a lot like first order logic or sentential logic is what most programming is based on. So if you're a computer science major or you're thinking about that sort of thing, all of this is hopefully extremely helpful to you. And of course, we just finished something called categorical logic, right? So this is the subject of the preceding chapter. It was based on the words all, some, and not. and they produce relations of inclusion and exclusion among classes or groups, as we talked about them. So truth functional logic doesn't really work that way. Truth functional logic depends on how words like and, or, and if work in claims. So we'll be building claims that are much more complex than all, some, and not. This is much more versatile kind of logic than categorical logic. This is the one I really love, and this is kind of what persuaded me to become a philosopher. So, truth functional, I think we should probably note, means that the claims can be evaluated in terms of whether they are true or false. So if I said the cup is on the table, that's going to be true or false. It's never going to be somewhere in the middle, and it's never going to be both. Right? The cup's not both on the table and not on the table. It could be mostly off the table, but it would still be on the table or off of the table. So it's binary. If you're aware of, the computer language of ones and zeros, that is just a truth functional logic. Sometimes we call it bivalent. So, the textbook wants to persuade you that this stuff is extremely valuable. I don't want to belabor the point. This is what will really help you get through the LSAT, the entrance exams for legal schools, and the GRE if you're thinking about going to grad school. It's extremely beneficial, and if you want a whole list of reasons you should be interested in truth functional logic, I am happy to provide those, but I'm not going to right now because these videos are far too lengthy already. Okay, so, they want you to note, if you're not comfortable working with symbols, the upcoming sections on truth functional arguments and deductions might look intimidating, but they're not that foreboding, right? Or forbidding, I said, that's weird. Right? They say they start from absolute scratch, but I don't think they do. They jump immediately into truth tables and logical symbols. So I want to get started with our logical vocabulary. In your notes, let's get a section started for our logical vocabulary. They start immediately with terms, and I think we need to talk about some other stuff first. So let's go over to the other textbook. All right, so we're now looking at this other textbook. Again, I'm happy to provide it if you want it, but there's no homework out of it or anything. They refer to it as SL. So the first important thing to note is that capital letters are used to represent basic sentences. I've sometimes called these sentence atoms. They do not represent nouns, right? And I've gotten a few emails asking a question that this textbook answers that our other one doesn't. So I'm going to take some time to go through it. So let's consider this argument. Premise 1, there is an apple on the desk. If there is an apple on the desk, then Jenny made it to class. Conclusion, right? And we all know this means conclusion because I've said it a million times in class. Jenny made it to class. So that's obviously a valid argument in English, and we've talked about validity. That means if the premises are true, the conclusion cannot fail to be true. So there's an apple on the desk, and we have this rule that's always true. If there's an apple on the desk, then Jenny made it to class. If both these things are true, there's no way Jenny didn't make it to class, right? So it's obviously a valid argument in English. In symbolizing it, we want to preserve the structure of the argument that makes it valid. So they ask us, what happens if we replace each sentence with a letter? And they ask us to make something called a symbolization key. Your homework is going to involve making a symbolization key. So, or actually, I think I provide one for you. The symbolization key would just look like this. A would stand for there is an apple on the desk. B would stand for if there is an apple on the desk, then Jenny made it to class. And C would stand for Jenny made it to class. So you would then symbolize it just A, sideways, B, conclusion C. And this textbook notes there's no necessary connection between some sentence A, which could be any sentence, and other sentences B and C, which could be any sentences. The structure of the argument has been completely lost in this translation. That's a bad translation, right? We did use capital letters to represent sentences, but in so doing, we in no way preserved the logic that made the argument valid. So the important thing about the argument is that the second premise is not merely any sentence, logically divorced from the other sentences in the argument, right? We've lost something valuable there. The second premise, that's the if-then premise, contains the first premise and the conclusion as parts, right? Our symbolization for the argument only needs to include meanings for A and C, and then we can build the second premise from those pieces. So we symbolize the argument this way. So A stands for if there is an apple on the desk. So if there is an apple on the desk, then, and C stands for Jenny made it to class. Then Jenny made it to class. And our conclusion is just Jenny made it to class, right? Just to give you another look at, I'm sorry about that, the actual argument, we can see this exactly fits right in here. And we can see that our conclusion exactly fits right in here. By noting that the second premise is doing something special for it, it's not just any random sentence, it's comprised of other bits of the argument, we can get, I'm so sorry, this is going nuts, we can get an argument that looks like this. This preserves the structure of the argument that makes it valid, but it still makes us use makes use of the English expression if then. And this is where the other textbook picks back up. And we're going to build our logical vocabulary out of that. So the first thing we're going to note is capital letters, oh my word, represent complete sentences. They don't, my nails got really long. I'm sorry. Capital letters represent complete sentences. They do not just right? In that example, we had there is an apple on the desk. The A didn't just say apple. That's not a claim, right? The A represented this entire sentence. And then when we go to number 2, we have if there is an apple on the desk, then Jenny made it to class, right? And C doesn't just represent class. That doesn't mean anything. It means all of this. Then Jenny made it to class. So for our conclusion, oh no, that's not what I wanted at all. This needs to go down. I thought it would just go down on its own. Sorry, y'all. Okay. Now it's doing it. So for our conclusion, which I don't have a keyboard shortcut for that other thing, I'm going to continue to indicate it with a C. For our conclusion, we have Jenny made it to class. So we would make something a symbolization key, and logicians don't do a whole lot of this in the long run, but it's important to realize what's happening when we translate this into logical form. So our key would look something like this. A equals there is an apple on the desk, right? C would represent Jenny made it to class. Excuse me, I have to sneeze. Okay, I survived the sneeze. All right, so C is going to represent the entire sentence, the complete grammatically correct sentence, Jenny made it to class. So from that, in our new textbook, we have premise 1, which then just becomes A. We have premise 2, which becomes if A, comma, then C. And we have our conclusion, which is just C. And this captures all of it. Except, as that textbook points out, we still have these pesky guys hanging around. This should look like what we've been doing up until now. So, our first bit of logical vocabulary should include that capital letters are sentence atoms. They're bits of sentence that can be taken alone or put together, right? And then parsed in symbolic form. Sorry about that. The next bit, we have this fantastic little symbolization key that I also snagged from that textbook. So you might just want to keep this handy, but we're going to be going back and forth between it. We have some other symbols. So let's start where this textbook starts. This arrow is called the conditional, and it replaces the if-then. So to write this here on this word pad, I might write something like, where's my cursor? Okay, all right, write something like, we still have premise 1, but for premise 2, I'm going to write if A, then, and my computer converted it, so that's handy, then C, right? And that's going to represent that if-then. It goes between the two parts. It goes between the antecedent and the consequent. And it's handy that this is A and C, but that's not what those stand for, right? We know what those stand for. Those stand for there's an apple on the desk and Jenny made it to class. So, and then we get our conclusion, which again remains the same. Jenny made it to class. So this is what this looks like in full logical form. So it's important to keep these symbols in mind. These are like our negative symbol in math, and our plus symbol, and maybe our minus symbol, and maybe a division and multiplication. This is the entirety of the symbols in symbolic logic, and we're going to learn the truth functions of each one of these, how they affect the sentence and the relationships in the sentence. So we're going to go through them one by one. Each one has a different truth table, meaning it has different truth conditions, or the negation can change the truth conditions. So just like a negative changes what happens when you plus a negative with a positive, right? So we're going to go through these one by one. I apologize, I misspoke. There is actually one other thing in our logical vocabulary, and that's the parentheses. These function the exact same way they do in math. So if I have, 2 plus 2 times 2, I do the thing in parentheses first. So we do also use parentheses in this. I don't think any textbooks really point this out because we already know how parentheses function, and they function the exact same way. So if I said something like, if I go to the store, then I will buy coffee and milk. We would make a key that says S is I go to the store, and we maybe make C equal I will buy coffee, and, oh, that's obnoxious. Oh, I don't like that at all. Let me get rid of this, y'all. Okay. And then we'll make M represent I will buy milk. Right? So this then, just to give you an example of parentheses used, would be something like, if I go to the store, then I will buy coffee and I will buy milk. So technically speaking, all logic should be encased in these outer parentheses. Quite often we leave them out. Just like, technically 2 plus 2 should have been encased in parentheses. But we almost always leave it out. So if you saw something like this, that would be technically incorrect, but it's not to be worried about. The important thing is that your symbolizations have the same number of parentheses on the left side as they do the right side. So you can see I've closed each set of parentheses. Again, these work exactly like they do in mathematics. It's very intuitive. So intuitive even that very rarely does anyone mention it. Okay, so a quick note on the homework. Incidentally, I think this is going to be way too big. Let's make this a bit smaller, maybe a little bigger. I give out a worksheet for this bit of homework. And I will upload this to Canvas. The first bit provides the symbolization key, right? And this should be pretty easy, right? We just follow through it. So I've given answer examples. So the example here is, unless those creatures are men in suits, they are either chimpanzees or they are gorillas. And we would symbolize that based on this key. And the reason I want everyone to use the same key is so that I don't have to check every answer based on your key. So everyone please symbolize using these letters. That would be right. What if it was S, right? It gets wacky. And I start going nuts and I can't tell who's keeping up with everything and who's completely lost. So please use this key. This would be symbolized as those creatures are men in suits, or those creatures are chimpanzees, or they are gorillas, right? So we can see the ors in the sentences, and we can go back and look again at our logical vocabulary, right? And find the either or is that, and just insert it into our, wrong tab. Insert it into our sentences and symbolize it. We will be going over each of the symbols one by one in some future lecture, but this is all you need to complete this homework. So this is all I am going to include for this week. It's been a lengthy week for me. I don't know if it's been lengthy for you, but I don't see the need to go beyond this little bit of homework first. We're learning a new language. We're learning symbolic logic. So please don't overthink this. Those creatures are not men in suits, right? You're just going to consult this and see what a not is. It's a negation, right? And then you're going to consult your, I keep doing that, your symbolization key and find the sentence that you can attach that to and symbolize it using those symbols on that list and the letters here. Quick note, I realize that the disjunction is like this crazy slim little V. You can just use the V letter on your keyboard. I prefer you use the lowercase v in case you end up later on symbolizing something with an uppercase V, but it's not a huge deal. So let's just symbolize these sentences. And then part 2 asks you to do something that I have been wondering about for quite some time. Don't worry about section 2 yet. That will be your homework for next week. I'm probably going to ask you to take a picture of it, but for the time being, do not worry about section 2. That will be next week. So please just answer questions 1 through 5 in section 1. In the text box provided, and then we'll go on to learn about truth tables in next week's lecture. Thank you guys. I realize this represents a huge shift in how this class works. Believe it or not, it's actually a scheduled shift. It's just a lot easier to do when we have a whiteboard in front of us and we can work together as a class. Don't hesitate to ask me any questions you might have about this so far, and trust me when I say we will go very slowly through all this, and we will make sure no one gets left behind. So everybody have a great weekend, and I will see you next Wednesday.